The next operator that we're going to define is implication. But before I define it, I want to put this slide up because this is something there where there is a likely to be confusion. This is something that is not straightforward, something that is counterintuitive. So I want to make sure that you follow what the definition is precisely. And once we understand the definition, we go with that definition and forget that we have heard the word implication in English language before. Okay, so what is a conditional proposition or an implication? So here again we have two propositions P and Q. We can combine them by P implies Q, or we write it as P arrow Q. This is a proposition that basically is saying if P is true, then I want Q to be true. So P implies Q is going to be false only if P is true and Q is false. That's the only time the implication is going to be false. If P is true and Q is false, then P implies Q is going to be false. Otherwise, it is going to be true. So think about it like this. You can think about it as P implies Q is like a contract. P is something that needs to be done first. If it is done, then Q should be done. So if P is not done, then P implies Q is true. There is nothing to be done because you didn't satisfy whatever was required. And if P is true, that means the precondition was satisfied, but Q was still false. That means that we have a problem. That means P implies Q is going to be false in that situation. So let's look at the truth table for P implies Q. So the only place where P implies Q is going to be false is in the second row, because here P is true and Q is false. And all the other ones, P implies Q is going to be true. So if P is true, Q is true. P implies Q is true. If P is false, Q is true, then P implies Q is true. This is the part which is where people get confused the most, which is if P is false and Q is false, even then P implies Q is true, because in this case, since P is not satisfied, we don't have to worry about Q. Once again, this is a slide I'm going to mark as important. I'm going to mark it as double important because this is something that also has a potential for confusion. So I want to make sure that you understand this slide and why this truth table is working the way it is. So let's look at a little bit more on P implies Q. The conditional operator is implied as a guarantee. If the condition is true, then the conclusion is expected to be true. So here, let P be it is raining, let Q be that there are clouds in the sky. P implies Q means if it is raining, then there are clouds in the sky. Note that we are not saying whether it's raining, we are not saying whether there are clouds in the sky. All that we are saying is if it is raining, then there are clouds in the sky. So if it's not raining, the above statement is true. If it's not raining, then this statement is true. The guarantor hasn't lied in this case. The only way the guarantor would have lied about this statement is if it was raining, but there were no clouds in the sky. There may not be any cause and effect relationship here, so we're not necessarily going to say that P is somehow going to cause Q to be true. So we could have something like if snow is black, I can fly. We'll find out. Some more things on P implies Q. The English terminology, we write this as P arrow Q, or we can write it as if P then Q. We also write it as P implies Q. We also write it as P only if Q. P is a sufficient condition for Q. Q follows from P. Q is a necessary condition for P. Q if P, and so on. A little bit more on P implies Q. Let's consider this statement. If you get more than 90% in this class, then you will get 4 points in this course. What is its true value based on the grading scale that I assigned yesterday? Okay. Let's look at some more propositions that are related to the implication operator. So let's look at this statement. If it is raining, then there are clouds in the sky. So here P is it is raining. This is P. Q is there are clouds in the sky. We can create another statement called Q implies P, which is what we'll call as the converse, which would say if there are clouds in the sky, then it is raining. We also could ask another statement. We could also create another statement called inverse, which is not P implies not Q. In this case, it would be if it is not raining, then there are no clouds in the sky. We could also create another statement, not Q implies not P. This is what we'll call contrapositive, and this says if there are no clouds in the sky, then it's not raining. So let's try to see if we can fill this truth table to see which of these statements are equivalent, or if they are equivalent, maybe they're not equivalent, etc. So we have two inputs here, P and Q. So we're going to fill the truth table. For P implies Q, the converse, inverse, and the contrapositive. One thing I want you to do here is make sure you review this truth table completely. I want you to identify why these entries are filled the way they are, and if there are any doubts, this is something we should discuss in class. This is something that you should ask me in the class. Alright, so let's first make a few observations about this truth table. One thing I want you to observe is that these two columns are identical. That means that the original implication and its contrapositive are identical statements. If one is true, the other is going to be true, and vice versa. These middle two columns are identical to each other. In other words, inverse and converse are same statements in terms of truth value. If one is true, the other will be true, and vice versa. However, these two are not the same. In other words, the implication and its converse or its inverse may not have the same truth value. It's possible one of them is true, but the other one is not. We have reached a check before you go slide one more time. So let's say P is true, Q is false, R is true. What is the truth value of all these propositions? If you have understood this, go ahead. If not, be sure to check with me or the team. Once again, the answers are at the bottom of the video. but I want you to check the answers only after you have done it for yourself.